Welcome to This Explainer. Today, we're diving straight into a massive paradigm shift in modern software engineering, safely orchestrating third-generation autonomous CLI agents. We are way beyond the days of simple inline auto-completion here. Today's terminal agents, like Google Antigravity or Anthropic's Claude Code, are completely autonomous actors. They can execute complex, multi-step planning and manage directory-wide execution all on their own. But with all that incredible power comes a really critical need for strict structural governance.
So what happens when an autonomous coding agent actually forgets the rules? It's a fascinating question because while these agents are brilliant at multi-step planning and recursive tool invocation, extended autonomy brings a hidden, inherent threat. Let's be honest, if you just unleash a powerful agent into your codebase without establishing absolute boundaries, things are going to get messy and fast.
This threat is known in the industry as instruction drift. You have to think of an agent's context window as a finite cognitive budget. As the agent is working, reading files, writing code, firing off tools, and parsing these massive build logs, that context window slowly fills up with low-value text. And as that context decays, the agent essentially forgets the initial guidelines and those core architectural boundaries you set for it in the first place. To put that into perspective, think about two completely different realities. In a session without guidance, you get pure chaos. Instruction drift kicks in, and the agent's generated code starts to just wander completely outside your enterprise-style guidelines. It might even introduce nasty security risks or start hallucinating calls to legacy APIs. But contrast that with a guided session. Here, everything is bound by clean, deterministic verification and persistent context. You get strict, predictable compliance with every single output.
The absolute crucial point here is that your role as an engineer is fundamentally elevating. It's no longer about manually typing out boilerplate syntax. No, your value is migrating. You are becoming a systems architect. Your job is defining clear intent and establishing the exact boundary conditions that these generative models absolutely must operate within. Because at the end of the day, these models cannot simply infer your unstated business rules.
Which brings us to the ultimate operational question. If these models can't just guess your organizational security policies or your specific architectural trade-offs, how do we physically and systematically anchor them to our enterprise standards so they never wander off course?
The heroic solution to this is what we call declarative system anchors. Specifically, files like Gemini.md and Agents.md. I want you to picture these as glowing, protective shields sitting right at the root of your code repository tree. They aren't just basic text files. They are strict invariants and forbidden anti-patterns that continuously guard your entire project architecture. To really visualize how these glowing shields enforce constraints in real time, it helps to look at agent governance through the lens of a clean, three-part bento grid layout. This bento grid perfectly breaks down the lifecycle of safe, governed agent execution. So let's walk through this operational loop step by step. First, you have your system rules anchoring the agent's context. Second, the CLI actively reads those guidelines during code compilation. And third, automated alerts jump in to flag and correct any non-compliant code before it ever gets the chance to save to your disk.
Let's start with Bento Block 1, Anchoring Agent Context.
Building the baseline for agent safety is all about proactive memory persistence. Those root-level markdown rules, our glowing shields, are instantly injected at the very top of every single CLI session. Because they act as explicitly externalized memory, they instantly block forbidden packages, shut down security risks, and prevent legacy API usage. It literally guarantees zero instruction loss. Plus, here's a fun fact. By deferring the loading of heavy, unnecessary tools until they're actually needed alongside these rules, enterprise systems can save up to 191,000 tokens of context. That keeps your agent incredibly hyper-focused.
Moving right along to Bento Block 2, Reading Execution Guidelines.
Once that context is completely anchored, we have to look at how the CLI engine actually reads and obeys these guidelines during active execution. Third-generation agents don't just blindly stream commands and instantly overwrite files anymore. Instead, they use a tightly controlled observe, plan, act, verify loop. The CLI is constantly checking its actions against your root-level shields, bringing in test runners like PyTest or Jest, and utilizing static analyzers to absolutely ensure every single mutation is valid.
This loop introduces a really critical control mechanism, mandatory verification gating. The agent is strictly forced to produce structured intermediate artifacts first, like an implementation plan.md file. Think of these plans as a versioned proof of work. It gives you, the architect, the power to review the agent's exact intent before any potentially destructive actions are unleashed in your environment.
And finally, Bento Block 3, the safety net.
Because look, even with the best plans in the world, an agent might still attempt something risky. We need a safety net to catch it mid-flight. Enter programmatic interception via SDK lifecycle hooks. When an agent attempts an action that breaks a rule defined by our shields, an alert triggers instantly. It flags and actually corrects the non-compliant code before it is ever saved to disk. It's an incredibly powerful, continuous, automated boundary layer.
These hooks have very distinct roles. Inspect hooks provide your non-blocking telemetry and auditing. Your decide hooks, they are the ultimate bouncers, acting as blocking middleware that enforces security policies to outright deny destructive operations, like accidentally dropping a database. And transform hooks are super clever. They dynamically rewrite payloads in transit, scrubbing sensitive credentials on the fly so they never leak into the model's memory.
But what if the agent hits a random runtime error and just keeps stubbornly trying to fix it, failing over and over? To prevent catastrophic token exhaustion in those infinite react failure loops, you implement strict circuit breakers. You set a max iteration cap, say 5 to 10 loops. If it can't converge on a passing test by then, bam, the circuit breaker trips. It halts execution and safely reverts the entire file system back to a clean, shadow state.
Which leads us to the big picture. Scaling with trust through multi-agent orchestration.
When you zoom out from the bento grid, this deterministic verification is the true endgame of the technology. It's what allows teams to trust vast multi-agent orchestrations at a massive enterprise scale. Because your environment is flawlessly protected by those root-level shields, a lead coordinator agent can dynamically spin up dozens of isolated subagents in parallel. Whether you're running a hierarchical orchestrator dispatching tasks or a peer-to-peer setup for code reviews, you can have subagents simultaneously refactoring back-end APIs and writing front-end tests in totally isolated Git work trees, all with total confidence.
Ultimately, this is the massive shift in your day-to-day work. By establishing these glowing architectural invariants and robust safety loops, you are completely freeing yourself from the weeds of manual syntax generation. You elevate your entire workflow to focus purely on intent articulation and high-level multi-agent system design.
So I want to leave you with this provocative thought as you start implementing these incredibly powerful tools. As your agents execute tasks across your codebase, are you truly, structurally governing them with root-level shields, or are you just crossing your fingers and hoping they follow the rules? Think about it. Thanks for joining this explainer, and happy architecting.